I'd like to introduce our first speaker, Dr. Moriba Jah, who is an American space scientist and aerospace engineer known for his contributions to orbit determination and prediction, especially as related to space, situational awareness, and space traffic monitoring. He is currently an associate professor of aerospace engineering and engineering mechanics at the University of Texas at Austin. Jah previously worked as a space navigator at the NASA Jet Propulsion Laboratory, where he was a navigator for the Mars Global Surveyor, the Mars Odyssey, the Mars Express, the Mars Exploration Rover, and his last mission was the Mars Reconnaissance Orbiter. He is a fellow of the American Astronautical Society, the Air Force Research Laboratory, the International Association for the Advancement of Space Safety, and the Royal Astronomical Society. Jah was also selected into the 10th anniversary class of TED Fellows.
That's good enough.
No, there's more. He was also selected into the AIA class of fellows and honorary fellows in the year of the 50th anniversary of Apollo 11. The AIAA confers the distinction of fellow upon individuals in recognition of their notable and valuable contributions to the arts, sciences, or technology of aeronautics and astronautics. And Wired magazine recently named him one of the top 25 people racing to save our planet. So without further ado, welcome Dr. Jah.
Anyway, thank you very much. Appreciate everybody taking time out of your day to be here. I'm honored to be here, especially for this inaugural SpaceATX. Hopefully, it's one of N where N's a large number. All right, I just wanted to say something. So, thanks very much, and I want to talk to you a little bit today about what we're doing in terms of this, space sustainability idea. All right, so satellites. So what? Well, people just, I guess, in general, take for granted the number of services and capabilities that we depend on, every day that are space-based. And I guess a bit of interesting news is that more and more of these critical space services and activities are becoming space-based kind of things, including the internet itself. Clearly, we all know about global positioning system, go from point A to point B, and your blue dot on your cell phone, and I use Waze. I love to use Waze and these sorts of things. I can't remember the last time that I actually unfolded a map to find my way around a place. And definitely, if you've ever had to find your way in a city with one of these fold-out maps, you know how horrible that experience has been. Satellites also provide information on weather. Line of sight for somebody on the ground to look out your window to see whether or not you should go outside and that sort of stuff is very limited. But line of sight from something that is space-based, it gives you a lot more capability. And a lot of lives have been saved because of space technology. And the cool thing about satellites is they don't just detect things in visible wavelengths. You can have multispectral data collected by satellites that they can kind of peer in and see different types of phenomena to help explain and predict climate change and these sorts of things. But we also use satellites for things like agriculture, and we can see kind of water content in the soil and the minerals, and where does it make sense to grow a certain crop from one year to the next and that sort of thing. Very important things. Education, as it turns out, I know that the internet is something that is ubiquitous for folks like us, but there are a lot of people around the globe that still have no access to this, and some companies are trying to do what they can and provide global internet. And I guess one of the things that I'd like to say, just briefly, is that when I was going through school, I was born in the US, but I was raised in Venezuela, and one of the interesting experiences that I had in school is that at some point in class, I was learning some stuff, and what I learned allowed me to make observations of the world around me, and I could come up with my own hypotheses. And I'm like, now I can predict, how long it's going to take that rock to fall from here to there because I understand physics and this, that, and the other. And that's something that nobody can take away from you. So knowledge is a very empowering kind of thing. So anyway, people are trying to use space-based capabilities to help make knowledge more commonplace across the globe. Not a bad thing. For folks that are more worried about what's in your pocket or wallet, as you travel, more and more bank routing services and that sort of stuff are also space-based. And in fact, a lot of the time stamping on financial transactions are based on position navigation and timing services. So those go away, that's not a good thing. Yeah, so what if satellites disappeared? You can all imagine it's a bad day for a lot of people around the planet. So interestingly enough, what is this population of human-made objects around space? On the far left side, there's this graph that comes from NASA's Orbital Debris Program Office, just down the road at Johnson Space Center in Houston. And so the current catalog, the largest public catalog or database of human-made objects around the Earth is roughly around 26,000 objects, ranging in size from the cell phone all the way up to the space station, school bus-sized objects. And of those 26,000, roughly about 3,000 are things that work, and everything else is garbage. However, on the far right, it says assumed space object population because we hypothesize how many objects go down all the way to 1 millimeter in diameter, like a fleck of paint. And a fleck of paint moving at the right speed, colliding with one of these operational satellites could render it useless. And I'm going to show you, give you some context for that in a little bit. But we can't track things as small as a speck of paint. And so it's this untrackable population that are kind of like random bullets. So just think a bullet is very small, but moves at high speed, kinetic energy, large damage when it impacts something. So that's kind of a way to think about it. And so people around the globe kind of think, there's probably roughly about 500,000 objects that could cause the loss, disruption, or degradation of these space services. But we can't, again, track things that small. So out of roughly 500,000 hypothesized objects, we only track about 26,000. So out of everything we should worry about, we can only track 1% of the population that we should be concerned about. And of that 1%, only 6% works. And everything else is garbage. So what we're doing to the oceans with plastics and stuff, we're doing with space. No surprise there. All right. So to give you an idea of how the population has grown, here's a cool video from Analytical Graphics. And this kind of says, okay, from Sputnik in 1957 to now, roughly, what does that population growth look like? We as a species are awesome. And then in 2007, we had a huge breakup event in low Earth orbit. Chinese blew up one of their satellites in an orbit that is too high for most of that stuff to re-enter anytime soon. And then in 2009, two things collided and became many more objects. So whenever something collides or explodes, when it breaks up, it becomes many more things. To give you an example, this is a simulation of that collision in 2009 between Iridium and Cosmos. And it's not for you to look at it quantitatively, it's more for you to just get an idea qualitatively. What's the behavior of stuff that when things match position but don't match velocity, these bad things happen. So this is another video from Analytical Graphics, and again it's like a simulation, but it kind of gives you an idea of how these objects disperse after these collisions. And the bad news is you're going to see how this stuff just wraps around the planet and then becomes like a little belt. We're kind of becoming like Saturn here. We have rings of crap. Yeah. So that's how extraterrestrials are going to get to know us. It's like, oh, Saturn has rings, but this thing called Earth has many more rings and shells of garbage. So this gives you an idea, how these things start getting dispersed. And you add on everything else, and things look busy, and they are. All right. So this is a snapshot of the current population of objects in space. We developed this here at UT Austin. I'll go into this here a little bit so you can kind of see it. kind of in real time. But yeah, we're basically developed kind of the first crowdsourced space traffic monitoring system here at UT. Here planned sources to the space object population in the next few years. And you can see, SpaceX, OneWeb, Blue Origin. It's actually Amazon. They corrected me. Project Kuiper's Amazon. So it's not Blue Origin. I said, okay, Jeff Bezos, same dude. Anyway, yeah, tomato. But anyway, you can kind of see launch year, number of satellites. But for those that can't read the small print from all the way up there, here's that same information. But interestingly enough, you see, okay, orbital altitude, number of satellites. The fact that these aren't uniformly distributed means that they're sharing the same kind of neighborhoods, and so we need to think about how to manage that neighborhood traffic. All right. So if you don't understand what the problem is, I'm going to I'll be like Dukes of Hazzard narrator. What them Duke boys don't know is that. So space is like Wild West. Interestingly enough, even though with the Outer Space Treaty you can't claim any part of space, even though there's somebody that actually sells deeds to the moon and Mars, if you want to spend your money that way, go ahead, but I don't think it's going to hold in a court anywhere. But effectively, it's kind of like squatters' rights, right? I mean, once Elon puts up 30,000 objects in a given orbital regime, it's going to be hard for anybody else to participate in that same orbit. And so there is a gold rush of what can I launch as soon as possible to lay my stake in space, and for all intents and purposes, it's like squatters' rights kind of thing. So that's going on. There's a potential to make lots and lots of money in space. That's not a bad thing. Okay, so making profit, that's not bad, but that is motivation to get stuff in space as soon as possible. Launch services are becoming more accessible. You're going to hear some of that stuff today. There's some folks that want to put satellites in space for a variety of reasons. Hypergiant is probably going to talk about that. You got the folks at Firefly that are making launch more accessible and that sort of thing. That's not bad. Transcontinental Railroad did great things, opening up business between East and West Coast, right? But we need to proceed with kind of the vision for long-term sustainability of the environment. So we put things in specific highways in space, and I'll show you this stuff, but there are no rules on the highways. So that's not so good. So we need to do something about that. One of the things that I find very interesting in terms of sustainability in space is that the people that talk about space sustainability don't really account for how people have achieved sustainability in other domains. And interestingly enough, in my travels, I have had the fortune of meeting Native Alaskans, Aborigines, and some of these indigenous people, they have thrived for thousands of years with an environment and understanding how to be in balance with that environment. And so one of the things that we're trying to do in our work is looking at things like traditional ecological knowledge and saying, hey, there's some tenets that have been developed over millennia by certain indigenous people that understood what sustainability meant. We should look at those and try to use those to inform us how we can achieve sustainability in space. And some of them are obvious, like empirical data, understanding what your relationship is with other things in the domain, how to behave in a way that's sustainable in terms of maybe creating registries and databases, sharing information. There's understanding past and current uses. What are the different intentions of how to use space and understanding those, ethics, developing norms of behavior, cultural relationships that we have with space. So all these things are tenets of traditional ecological knowledge that we should use to inform how we move towards space sustainability. And basically look at these three different spheres, right? Again, ethics, norms of behavior, how do we want people to behave in space? How do we put these things into practice? Mutual respect for each other, but also understanding the differences in culture. Here's an example, right? It's like there are these 21 guidelines that have been adopted by the United Nations Committee on Peaceful Uses of Outer Space in Vienna. I've had the fortune of participating in some of those meetings. And so the question is this, okay, we have these 21 guidelines. when it comes to implementing these guidelines, will everybody around the globe implement this stuff in the same way? Probably not. If you want to talk to Arab nations, what is Sharia interpretation of the guidelines? How will Jewish people interpret those guidelines? How do Americans do that? What about Chinese? So even though they're common words and everybody signed yes, how these get implemented, that happens through a cultural lens. And not understanding that and not embracing the fact that that's how it would happen is just naive and doesn't get us to something that makes a lot of sense. How does American culture manifest itself in space? Let me give you an example. US satellites tend to maneuver on Tuesdays, Wednesdays, and Thursdays. Why? Well, you don't want to do it on Friday because if Murphy's Law, something bad happens, you don't want to explain to your family, you got to stay late at work. You don't want to come in during weekends and holidays, and you certainly don't want to do it on a Monday morning kind of thing. So most American satellites maneuver on Tuesdays, Wednesdays, and Thursdays. That's a cultural thing. A lot of US satellites also do optimal maneuver type stuff. Fuel is precious, and everybody's like, I basically use the least amount of fuel to get from here to... So optimal trajectories, all that stuff. And whenever somebody behaves in a way that's differently than us, well, those people didn't maneuver optimally. Red flag, that's a threat. No, maybe other cultures don't put that much value or emphasis as we do on certain things. So we need to understand different cultures to help explain all these different behaviors in space and not assume that it's uniform. All right, so this thing called space situational awareness is just decision-making knowledge in space. The only takeaways that I want from here is that there's a space environment that's harsh. It affects and impacts how we operate in space, and that needs to be understood better. We don't fully understand that. Moving to the right, aside from hazards, we don't really know how to predict exactly where everything's going to be at some point in the future, so we need to be better at doing predictions. And then, yes, there are threats. Every single domain of human activity, okay, whether it was maritime, crossing lands, all that stuff, suffered and still suffers from malintent. To think that space is just a place of utter benevolence and goodwill is ridiculous. That doesn't make any sense. So you better believe that companies are going to be trying to one-up each other and trying to disrupt the other person's kind of bottom line to make money. That has happened, and that will happen, and that's only going to get worse. But what's the body of evidence that we can bring to the table to reconcile that and to basically say, yeah, Jimmy schwacked Moriba's satellite, I could tell because Jimmy did this, that, and the other. Right now, we don't have that body of evidence. So that's part of why it's kind of the Wild West. What do we need to get to? We need to make space transparent. We need to bring accountability, and we need it to be predictable, okay? So far, we still don't have a globally open and accessible space object and event database. We're trying to create some of that here at UT, or show what that might look like. Again, body of evidence of behaviors in space so that different people can hold each other kind of accountable. We need that. It needs to be independent. And then in terms of predictability, listen, the more that we can communicate with each other and say, hey, you know what? Next Tuesday at this time, I plan on moving my satellite. So maybe you might want to be careful or move out of the way or take that into account. These are the sorts of things that we should be doing more often. Kind of essential ingredients for success. Again, this idea of an independent activity that can corroborate this evidence is needed. Look, India blew up one of their satellites in February, I believe, of this calendar year, and the Indians are like, in 45 days, all the debris will enter. They did, the Jedi mind trick kind of thing. Those aren't the droids you're looking for. 45 days, all the debris. And then the U.S. is tracking stuff, and the U.S. is like, no, actually there's evidence that some of that stuff is going to be up there for like decades. Who's right? Who's wrong? I don't have the evidence so that I can independently verify or corroborate that stuff, and that's not good. So the he said, she said scenario in space does not lend itself to long-term sustainability. So we need a global pool of evidence that people can draw their own conclusions, and then let's compare notes and see where we agree and where we disagree about that stuff. Something else that I'm working on is the World Economic Forum is developing a space sustainability rating, kind of like 5-star restaurant, 5-star hotel, 5-star sustainability rating for people that are going to be operating in space to try to incentivize sustainable behavior. And so with the World Economic Forum, European Space Agency, MIT, Bryce Technologies, and myself are working on developing that right now. And to help make that happen, I'm also trying to develop a carbon footprint analog that I'm calling a space traffic footprint. So basically, you can think of the space traffic footprint as the burden that any object imposes on the safety and sustainability of anybody else. When I get in my car, I put it in reverse. As soon as I start moving that vehicle, okay, I am now burdened to other pedestrians and other drivers on the road. They have to take me into account in their calculus. Even though they know exactly where I am, they have to take me into account, just like I have to take other people into account. And so that burden is something I'm trying to quantify and kind of assign to every given object in space, dead or alive, so we can have this footprint, so we can understand, okay, yeah, that has a larger footprint, and these people maybe need to pay more money to operate in this way, or space insurance premiums can be charged in that way, or you can put a bounty on specific objects and say, yeah, $10,000 to remove this thing because it has a larger footprint. But until we have sustainability metrics in place, none of that is really something that makes a whole lot of sense. It's not monetizable kind of thing. So we're working on that. Anyway, these are just some criteria that I came up with. It has to be independently measurable, must be something that can be updated. People have to be able to find a way to be able to reduce it. You have to give people the power to reduce their footprint. Anyway, so these are just kind of tenets that made sense to me. All right, we have a few challenges, if you haven't been able to see that so far. Again, space environment is harsh. We know how to somewhat operate in it, but it does can do a lot of damage and is culpable for causing loss, disruption, and degradation of services. But how do we know for sure? So there's this space event happened Halloween 2003, disrupted a bunch of different satellites. But because people were able to maybe share some of these anomalies with each other, it's like, okay, yeah, the culprit is the space environment. But what if that's just not so evident? Being able to figure out, again, attribute cause to some anomaly and be able to say, yep, it's not due to what somebody else tried to do to me, it's due to Mother Nature. That is very important. It's going to become more important moving forward. As in every community, our community in space also suffers from large confirmation bias. And it's not like we have these benchmark data sets where everybody can compare their answers and that sort of stuff. Everybody has their own algorithm, their own tool that they develop with their own data. And of course, their stuff is the best. Oh, I have the best athlete. Well, I have the best, you know. So we have to do something about that. And hopefully some of the work that we're doing here at UT can help get rid of that. We also make lots of decisions based on incomplete data and partial information, and we get into a lot of fights about this. It's a circle. No, it's a square. It's a circle. It's a square. It's like, well, you're both right, and you're not absolutely right. And so part of the reason why we need to combine more and more and more disparate sources of information, we want to aggregate as much as possible. We want to create a big data problem for ourselves in space so that we can get to understanding something that is truer. We'll never get to the absolute truth for a variety of reasons, but we want to get to something that's truer, and we only get there by sharing information, okay, and perspectives. So Astrodynamics 101, basically the thing that motivates motion of objects in space. So we have this thing called the Earth, and it's not a perfect sphere. It's also not flat. And so that causes most of the kind of this curvature of space-time thing that satellites experience. We have the moon. It has gravity. The sun as well. Somebody years ago, when I told them about solar gravity, they're like, man, that whole PhD thing that you got, you should give it back because that makes no sense. And he took out a lighter and he flicked it in front of my face and he pointed at the flame. He's like, hey man, that's the sun. It's just a flickering flame. I'm like, yeah, you don't argue with those people. You leave them away. All right? And so the sun also has these things called photons. They interact with different surfaces and impart momentum, even though that they're massless. But they heat surfaces up, and then satellite re-radiates heat, so that causes accelerations. The Earth also reflects solar energy, and that causes accelerations on satellites depending on how far from the Earth you are. And then the Earth actually re-radiates heat as well. And depending on the size of your antenna, that can also cause some accelerations. There's these things called tides. that also influence satellite motion, other planets, and relativistic effects. All right, so what we want to be able to get to, some of the challenges, is most of the objects in space don't report their identity. So we have an identity crisis of objects in space. We'd love to be able to do what other people in like biological systems do, which is identify individuals within a certain species, tag those things, formulate some hypotheses, right? Track their behavior and interaction with their environment, test the hypotheses, identify correlations, and hopefully infer causal relationships. We can't physically go up and tag stuff in space for a variety of reasons. So we have to do that algorithmically. We have to do that with physics. We have to do that remotely, and that's a big challenge. Here's a plot of detections from a really great sensor called the Space Surveillance Telescope, developed, funded by DARPA, built by MIT Lincoln Laboratory, currently in Australia, in Exmouth. And this is a single night's worth of observations. The good news about the Space Surveillance Telescope is that it detects lots of stuff. The bad thing about the Space Surveillance Telescope is that it detects lots of stuff. And so basically what you're seeing is the difference between tracking objects and simply detecting them. All the dots that are black are things that we track, which means we've detected something and we believe we know what it is, and everything else is unknown. Okay? So there's every night the sensor is generating all this clutter of stuff that's unknown. So detecting is not sufficient. We need to get to the tracking, which implies identification. Another way to say it is if you have a bucket of detections at different times, how do you figure out which object is which and connecting those dots between all those detections? That's part of the hard work that we have to do in this endeavor. We are using things called ontologies, which is just a kind of fancy way to say it's a semantic description of a given domain. And can we semantically label these relationships and use that in something like a knowledge graph to then avail ourselves of the power of big data science and analytics? So that's something that we are creating and developing here at UT. We have this thing called Astra Graph, and it has 3 levels. We have raw information on the bottom level, kind of the middle layer is the graph database, and the top layer are apps that can interact with this sort of thing. Once we have data that we're trying to collect, we can then try to use clustering algorithms to figure out what are the relationships between things in different kind of dimensions of that graph, whether it's Vietoris-Rips complex or it's like Voronoi diagrams and that sort of stuff. So these are things that we're looking forward to actually exploring. So we have some unsolved challenges. I'm not going to go through this. You can see that's very verbose. That means that that's job security for me, is what I'm trying to tell you. All right. So why is UT Austin kind of uniquely suited to do this stuff? A couple of things. One, most of the folks that are working some of these problems operationally have high security clearances, and things are classified and all this other stuff. And let's just put it this way, it's not like that's openly subject to scientific scrutiny. So one of the things that academia can do, and is well suited for, is bringing that to the table, is wrestling with these concepts and subjecting things to peer review and that sort of stuff. We also are able to explore the art of the possible and not just look at state of practice. So state of practice tells us there's some problems, but we're free to explore art of the possible. Other folks only can look at very incremental, very constrained solutions. There's this thing called Track 2 diplomacy that people talk about in Washington, D.C. And Track 2 diplomacy is basically as follows. I think still, to this day, NASA is still not allowed to have any sort of government-to-government meetings with China, for instance. I have a Chinese student in my research program. You know what I'm saying? It's like that sort of thing, being able to work, being able to work with people from all these different countries where on the government-to-government level, things may be difficult, but on the academic, scientific level, there's more freedom, might just show people, hey, maybe we can get along to some extent. And then all these people that want to fly these satellites, folks like Hydrogen as well, where does that come from? It doesn't just grow off of trees. And so academia is well suited to collaborate with private industry and help develop that workforce. Another way to say this is I want to create the Hogwarts for space here at UT Austin. Okay? And really looking at space safety, security, and sustainability, and saying, listen, we have a McDonald's observatory, we have astronomers, they can tell us, hey, maybe you can use these techniques to look at space debris. That might be helpful. You have environmental sciences, environmental law, social sciences, understanding human behavior and how that might manifest in space. Astrodynamicists like myself that understand the physics of motion of all these objects. There's just a lot that we can do here that's very transdisciplinary. And when I say transdisciplinary, I mean the solution can only be had by the fusion of all these disciplines. Not interdisciplinary, not multi, because that's still kind of stovepipe. Transdisciplinary means the solution only happens by the mixture and that fusion of all those all those disciplines. We'd love to, again, like you can be a Ravenclaw, I can be Gryffindor, but all of us take the dark arts class. How cool is that, right? So it's like the next congressman knows what a telescope looks like. The next astronomer knows how difficult it is to reach consensus to pass policy. These are important things for all of us to get kind of a grasp on. So that's what we want to create here at UT. All right, who cares about this stuff? Oh, let's see. I've been on panels with chief scientists of the Air Force, NASA, DARPA. Representative McSally is in there in the picture, working with the FAA, Commercial Space Transportation, U.S. Strategic Command, Major General Heidi Brown, the current administrator of NASA, Jim Bridenstine, cares about this stuff. There's Congresswoman Martha McSally from Arizona, cares about this. I testified formally to Congress, to the Senate a couple of years ago about the stuff that I'm doing here. Here's Representative Babin from Texas in the House Science, Technology and Space Committee. He cares about this stuff a lot. This is, on Capitol Hill briefing about a lot of these things. I got to meet President Mata Bio from Sierra Leone, who wants to bring Sierra Leone into the whole space age and how to do STEM research in that country. Talked to Al Gore about a lot of these problems and that climate change and environmental protection shouldn't be used interchangeably. Like, okay, space debris isn't necessarily a climate change thing, but that near-Earth space is a finite resource and is in need of environmental protection. And so, how do we achieve that sort of stuff? And here's, me at the United Nations delivering something at the UN floor in Vienna recently. People in Australia care about this stuff too. They got telescopes, they got lasers that they're trying to point to stuff in space and nudge stuff around. And just going around talking to folks like yourselves in different venues. And that's the bottom line. It's not enough, okay? I'm not enough. As much as I do this stuff, as much as people are listening to me, right? I am not enough. And let me show you some stuff. See if we can get this internet connection here going. Just restart this stuff. So yeah, so if you go and just Google this Astra Graph kind of thing, there we go. So all this stuff, currently tracked objects around Earth. You can see this ellipse right here. That ellipse is, all those dots, those pink dots came from a single object that blew up a couple months ago. Okay, single object produced all that. Here's a plane, orbital plane right there. Here's one right there. Things that blew up like August of last year. Here's the geo belt that you can see, this outer belt, Goldilocks. That's where we put communication satellites. Once that becomes unusable, you can forget about DirecTV and a lot of other stuff. Yeah, let's see something even more interesting here. Let's look at. Choose worldview 3. Here we go. So it's like, here's one satellite with different opinions, It's like, well, here's some opinion of where the satellite is. Here's an opinion where the satellite is. Like, who's right? If you said move out of the way, which one? Where is the thing actually located? This is a problem. So not only do we not track everything very accurately, we also vehemently disagree with where these objects are located at any given point in time. So have fun with that one, right? And then this is something that we just deployed yesterday for the first time. Think of it as the world's first near real-time, near-miss streaming activity. So you can basically go to this, and this is showing you and this is only just under 2,000 objects. The question is, out of these 2,000 objects, which ones are coming close, in a predictive sense? Which ones are coming within 5 kilometers, 3 miles, or closer to each other? And these are actual predictions. Look at the times, right? I mean, this is stuff that's happening, right? These close approaches are happening all the time. Here are the distances in kilometers, right? Number of objects, distances in kilometers. Here's a histogram of the speeds. Remember I told you, small fleck of paint at the right speed? So think of 1 kilometer per second as the speed of a bullet. So these are things that we actually track, which means they're as big as your cell phone, moving relative to each other 14 times the speed of a bullet. That's what's going on, folks. It's happening now, okay? Not tomorrow, not 10 years. This is happening now. Do I want to be an alarmist? No. What's the probability that any of these things will collide? Small, okay? But it's not 0. And it's just going to get worse unless we do something about it. So that said, I want to leave it here, and thank you very much, and maybe open it up for some questions. Thank you. How do you want to do this, Laura?
You can just ask questions from your seat. Just stand up and ask a question. Or there's slido.com, and if you go there, you enter capital D017 to ask a question electronically. And there's a question there.
You mentioned the challenge of bringing all the different influencers and participants together, the transdisciplinary, I think is the word you used.
Mm-hmm.
I'm curious, what momentum do you have, what challenges have you encountered, and what's your strategy for that, proceeding?
So I'll say that there are a few companies that have been very forward-leaning and have provided a lot of kind of the data. Companies that it's their business model to charge for this stuff, but for scientific purposes and stuff, they're providing stuff to me for free because I don't have the money to pay for the data. And just to show, what's the art of the possible and how to highlight some of this stuff. What I'd love to do is see like a consortium come from what I'm doing, maybe some sort of public-private partnership, and use what I'm doing as kind of like an initial seed and where that could go. Whatever database that we have here with Astra Graph, it's open source. All the algorithms that I use to actually track stuff with radar and telescope data is also open source. I put that out there. And so anybody can kind of copy it into their own kind of thing and they can use it as well. So I'm just hoping that just by demonstrating real stuff, people start getting it. Like, I'm not about PowerPoints and crap like that. Like some people want to just have nice slideshows, but it's like, yeah, you can go to these websites, you can see this is real stuff that's happening. So go ahead, man.
There's one quick follow-up question, sorry. So if you could request, whether it's from UT or practical, I've got a good friend that would probably love this data. He's a lot more capable than I am, data scientist, mathematician, programmer. Are there resources, 1 or 2 resources that you're on your wish list that would be, if I could find this in the next 30 days or the next 3 months or the next 3 years? Is anything like that, do you have a wish list that you put together that you're trying to knock out?
Well, I'm looking for volunteers, really. I mean, people from all over the globe are like, hey, I'd love to do research with you. How much money do you have? I don't have money to give out. I do have some data, I have challenging problems. I'm bandwidth limited. I can tell you, there's like a tsunami of data sources that I still haven't even started to get to ingest in this sort of stuff. I just don't have the people that can help me basically map that into these ontologies and schema quick enough. Like, yeah, it's like a huge bottleneck, man. And I feel so desperate, but I just don't have the balance. So yeah, anybody that's willing to kind of volunteer time to be part of the team, you know, share the glory kind of stuff. It's like, I give credit where credit's due. Like, it's not about me. Yeah.
If someone could bring you 1,000 retired scientists from various disciplines, do you think you could structure a team, sets of teams, coordinate with managers, and do something with 1,000 individuals? And the reason I ask that, I'm a retired scientist, different field. I love this. This is important. I like what you have to say. I love your passion. I'm talking with individuals around the country, around the globe. I might be able to get you 1,000 volunteers.
So here's what I'm telling you, right? Because I don't like giving knee-jerk answers. I like showing you that I've thought about it a little bit. The answer is yes. Okay? The answer is yes. Yep. Yes, sir.
Can you speak to some of the orbital dehumanization techniques that are currently being proposed for physical removal of the orbital debris and how viable they are?
Yeah, so, you know, there's this thing called the IADC, which is like Interagency Debris Coordination Committee, and it's mainly made of space agencies, and a lot of their debris mitigation guidelines have flowed into the United Nations Committee on Peaceful Use of Outer Space in those 21 guidelines that have been adopted for long-term sustainability. And a lot of them are very reasonable, right? It's like, at the end of your mission, like get rid of stored energy and remove anything that could, you know, make it kind of explosive and these sorts of stuff. Or remove your satellite after N years in orbit. But a lot of those mitigation guidelines now are unable to keep up with the traffic that we're experiencing and that we're going to experience in the next 5 years. Look, Elon just got approval from the US FCC to basically launch 12,000 satellites. I almost guarantee that before the end of the year, you're going to see him launch another 60. And he's already said that he wants to launch 60 at a time every 2 weeks next calendar year. And that's just him. And nobody's going to stop him. You know why? Because he is vertically integrated. He owns the launch vehicle and all that stuff. Nobody's going to stop Elon. Other people are going to try to catch up. Jeff Bezos is going to try to figure that stuff out. And that's only US. That's not even talking about what China and Russia are going to do. So the debris guidelines took into account a population, and they never were able to foresee this big spike in people just rushing to launch stuff. And now we've said okay to these folks. So reality is outpacing sensible regulation and that sort of stuff, unfortunately. Yeah.
Are you aware of anyone viewing space debris as an entrepreneurial opportunity? And if not, could you speculate about what sort of challenges might need to be overcome for there to be a market for cleaning this up?
Yeah, so I'll say this, right? The European Space Agency is way ahead of NASA in terms of that sort of thing. They are funding this thing called ESA Clean Space. This one professor from EPFL in Lausanne, Muriel Richards, she's going to be the lead of that. And ESA's already invested in debris cleaning technologies through Surrey satellites, you know, harpoons and nets so far. And they're going to automate collision avoidance maneuvers. So ESA is going to make this kind of thing happen, and they want to empower European industry to be able to monetize debris cleanup and all that other stuff. Sure, if you look at things in terms of mass and you say you want to remove the largest objects first, because those are the ones that, if they break up, become smaller things, that's a no-brainer. Which one to remove first, maybe it doesn't matter so much. But I think in general, until there is some sort of sustainability metric like this space traffic footprint that I'm trying to develop, I think that's going to make the whole debris cleanup more monetizable, because you'll be able to say, I can quantify the impact of me removing that one thing versus, you know, that thing. So, yes.
Okay, now there's a tsunami coming.
Mm-hmm.
It's been called 5G in communications. It features a thing called the mist, which is an edge of a cloud. Now, The guy who has about 50% of the cloud now is Jeff Bezos. And when I looked at the altitude that he's aiming at, it's a good altitude. It gets you the most spread to get the 1 millisecond 5G in cars at the speed of light. And it also gets, you're above the atmosphere. And so that's going to get, not only is there going to be a lot of, he can solve what took many years for us to build fiber optic up to the last internet, for this new internet just all of a sudden appear at a jammed, low-level type of ring around the Earth.
Right?
It bothers me. I didn't see that in any of your charts.
You didn't see
You
what
don't
in
see that.
the
You don't-
5G? Or
I didn't
what?
see 5G, yeah.
Okay,
They-
I didn't mention 5G, but I showed you all the Project Kuiper satellites and their locations.
Yeah, that was what got me worried.
Okay,
Because, yeah.
yes.
So, to cope with orbital debris, I think we need to first think about how we can generate a better guideline to satellite manufacturer or satellite operations. So I don't know what kind of activities or guidelines are now being done.
So I mean, here's what I want, right? I'm in the business of developing bodies of evidence. That's what I want. And I want to be able to show causal relationships between things. So it's not just, can I track stuff in space, but can I also ingest space environment, space weather data? You know, what is the sun doing? What's the geomagnetic activity? All these things. Also start linking it to hardware, you know, supply chain. What satellites are built with which pieces and that sort of stuff. So that over time, you can say, okay, this satellite stopped working and that, what's the common thing? Oh, they were both built by this individual, blah, blah, blah. Well, we should probably stop buying these parts but we have zero clue about any of that stuff because we don't have this aggregated set of information. So that's what that's the part that I'm trying to solve first. Yes?
It's not really what people or government are good at, but in your work with legislators, have you found any appetite for U.S. leadership in terms of setting up like enforceable rules and regulations that could help mitigate these issues in the future?
Yeah, so I can tell you, you know, my visits on the Hill, mostly Republicans have wanted to talk to me. You know, Democrats don't see the debris thing as a big enough deal because there's all this oceans, atmospheres, and climates, and you know, who cares about the debris thing? My guess is that the Republicans care more because they see this as an impedance to U.S. commercial dominance in space. So I don't care what the reasoning is, but they're the ones that are talking to me. So yes, they're motivated because they want to see U.S. companies based. They want to see, if anybody wants to do business in space, they want that to come through the United States. And so how can they empower and make that happen? Yes?
All the charts that you're showing are around the Earth's atmosphere. Is that from what humans are doing with debris? Like if you look around Mars, is there a lot less debris floating out there? Is that why people are trying to, you know, get humans to Mars?
So yes, there's much less human debris around Mars, but it's not zero. And I think, you know, I can't necessarily comment to what Elon is thinking about, right? But here's what I want to say. Humanity is growing, and the Earth has finite size. And so the thing is that we, at some point, as a species, if we want to survive as a species, we have to figure out how to live elsewhere aside from Earth. That said, people think, oh, just send people to Mars and just put them in this like dome and just, you know, do the Matt Damon, you know, science the crap out of stuff and just grow potatoes and it's all going to sort itself out. I have bad news. And part of the bad news is that we as a species, the way we look, the way we function is through something called evolution. And I think people have left evolution out of this whole equation. I don't know why, because to me it's very obvious. You can't just put a human being on Mars where there's no global magnetic field, there's no big moon that orbits every 28 days and that sort of stuff, and think it's just going to work hunky-dory. Like, that doesn't make any sense. So evolution is going to play its role. You put one of us that grew up in a place with mostly water and all that stuff, and again, the moon and magnetic field, someplace that lacks those things, it's not just about carrying that stuff with us. Like, these things affect us biologically, and Mother Nature will show us how that plays out. And my guess is that it's not going to be pretty. Yes.
Have there been any incidences when they launched the Soyuz rocket to go to the International Space Station of them hitting any of this debris or? And
They hit it all the time. Basically, there's evidence every single mission that this stuff gets pitted by stuff. So the answer is yes.
Okay, and then my second question is really non-technical, but there is this episode of Watchmen that's on HBO, and it said she was killed by space junk, and they had a big thing fall from the sky. Is there space junk falling into to Earth?
Yeah.
So this is hitting things?
Yes. The Earth is mostly water, so mostly whatever survives re-entry mostly comes in, in the oceans. I have a group of undergrads. I haven't shown it because it's not up and running yet, but hopefully in the next couple months. We are mining NOAA radar data. Turns out NOAA radar all over the US not only keeps track of storm cell activity, but also happens to detect things that re-enter the atmosphere. And so I'm building a crowdsourced NOAA radar thing that mines it for things that are actually re-entering the US. So, yes.
So you mentioned global warming, oceans, reasons why people are maybe distracted with other causes or needs. Do you have anything that kind of correlates or compare and contrasts the impact and the timeline that these things could impact our?
I don't, man. I'm not there yet. And one of the things that I definitely don't believe in is just, I'm not going to be an alarmist. So I'm not going to do that. I won't lie to you. How about that? Okay.
Real quick, what percentage of all that stuff is classified and military and the secret stuff you talked about versus what's known?
Let me show you.
That's cool.
So this is everything, right?
Yeah.
And then we have this group of people, amateur telescope people around the globe called CSAT-L, and they say that all these things are military classified objects.
Cool.
That's their opinion. I'm not going to challenge it. I'm just showing it. So,
Thank you.
yep. How are we on time?
We're good. Do you want to tell them about the conference you have in February?
Yeah, okay. So yeah, thanks for that. So we here at UT have partnered with the International Academy of Astronautics, major international organization, to basically have a space traffic management conference that'll be here at UT. It'll be in the MOVA auditorium in the new engineering building, February 19th and 20th of 2020. And a lot of these people that you'd love to kind of ask them questions, and some of the questions that you've asked, you can, like the guy who's the director of the Office of Space Commerce in the Department of Commerce, Kevin O'Connell, he'll be here. Other folks from DC, they'll be here at this conference. And so I really welcome you to mark your calendars, February 19th and 20th. And if you Google space traffic management, Austin, IAA, you'll find stuff there as well. So I'm looking forward to that. And we're also partnering with the United Nations Institute for Disarmament Research, UNIDIR, from Geneva. I'm a non-resident fellow with them, and they're going to basically help me organize the space security aspect to this. So dual-use technology. How do you infer intent of how people use stuff? One satellite with a grappling hook can be servicing, while another one with a grappling hook can be like hacking stuff. So how can you tell? Thank you very much.
Great. Thank you very much.